Hi everyone. Today we are going to discuss about the topic of 8086 minimum mode. Minimum mode operations that will be goes single processor mode. The processor controls the three buses. The buses names like address, data and control. The three buses we already known. Addresses is the unidirectionals, data is the bidirectional buses, control is the signal. It's the same single line. It also bidirectional from the control unit. Here multiplexed pin different functions at different interval times. It requires the peripherals simultaneously. Example, address and data are multiplexed. The microprocessor sends the command to one location to another location. That means sends the data. The data can be changed at the time states. Here, four time states are available: T1, T2, T3, T4. The T1 is the actually origin of the address lines. The T3 is the data lines of the T3 state. Microprocessor gives the instruction fetching follows by the time state T1, T2, T3 and T4. This is the actual the slides goes. Then we already know that timing in the microprocessor is the clock cycle state at least one machine cycle goes four time states. The time states are separated T1, T2, T3, T4. Each instruction cycle goes number of machine cycle. That means depends on the instructions in 8086 microprocessor. Actually, we know time equal to 1 by f. If your frequency known, the time also calculated. Okay. Then the mode of the operation is here minimum mode. The mn value goes to logical 1. That means supply VCC is given here. The M1 mode is activated in 8086 processor. Okay. 8086 logical operation and arithmetic operations sets the pins from A0 to A19. It matches the totally 20 bits address of the locations it wants to access. The value is not stored. Why? Because the pins follows a long time instructions. Then it will be re-returned to D0 to D15 data pins. The status lines, it will be fractions of second the next instructions are executed, where A0 to A19 is the actual address bus. The address bus goes, it will be clear, it will be purified from demultiplexers. A0, A19 is the exactly purified address from AD0 to AD15. In this diagram shows the 8086 processor extends its addresses AD0 to AD15. That means combined of address and data, it will goes here single directional bus to latch 8282. The latch has three control signals STB, OE and grounds. The signals of the values actually enabled by ALE signals. ALE, what is meant by ALE? Address latch enable. Once the latch is worked, it would be actually produce the purified address A0 to A19. That is exactly the diagram shows. In this diagram, the 8086 exactly gives the data transmission to transceiver IC 8286. In this receiver, actually dt by r, this pin is enabled, then the outputs of reception transition from a processor is goes to transceiver. The transceiver exactly executes the outputs to purified data D0 to D15. Here control signal is T and OE. What is meant by OE? Output enable. Here same, the signals decoder also added. The three memory signals is added, A, B, C. Then it will be produces 8 outputs. That means 3 cross 8 decoder we using here. IO write signal, IO read signal, memory read signal, memory write signal. The 4 control signals will be produced by 3 memory, IO, read and W control signals in 8086. The values which goes, if the value actually produce the same output in this diagram. The purified address is A0 to A19, the purified data is D0 to D15, the control signal is IOR, IOW and memory R and memory W. It is the exact output of the minimum mode operation. Here we fetching the CLK clock signals from 8284 IC, that means totally 18 megahertz. It can be divided by 3. The output is goes to 6 megahertz. The clock and reset and ready 3 signals are synchronized to microprocessor 8086. In this diagram exactly represent the signals interrupts. Interrupts, non-maskable interrupt, NMI, INTR interrupt signal, INTA the acknowledgement of the interrupts, then DMA is the data hold and data acknowledge. Here we see VCC equal to MN by MX, that is means MN mode is activated by giving the supply VCC, that means logical 1 operation. The exact diagram of the 8086 is shown in the slide. Totally 5 blocks are available. First one is clock cycle, second one is microprocessor, third one is latch, fourth one is transceiver, the fifth one is the decoder IC. That is the exactly the diagram represents. I hope you all understand about the 8086 topic. Thank you. We will see next topic in next video. Thank you all.